Now we'll go ahead and talk about significant values, aka unusual values, depending on your book or your teacher. Okay. Anyways, I'll come over here. We're going to be learning how we could pretty much do this by hand and also using technology, which could be the 3 graphic calculators that the CEOs and the 2 KIs. But let's go ahead and start with this. It's essentially to what we did for the purple rule and how we use that for the normal distribution curve. But here we go. So a significant value, aka unusual values, they pretty much tend to range within the significant low region and the significant high region. So our rule coming in general is saying that if you're using a purple rule, measure it down. If you can prove that the measures we see here happen to be measures greater than 2 centimeters away from the mean, to the right, then we know they're unusual values or equal to those 2 centimeters away. Or if the 2 centimeters is less than the mean or equal to them, 2 centimeters less than the mean, we know it's going to be unusually or significantly low or unusually low values. If it's somewhere in the middle, then we definitely see it as being non-significant or non-significant values, or aka usual values. Similar thing happens when we go, if we want to go, instead of doing the purple rule, and we go with the idea of the z-scores, so you can ask either or. We're doing the same thing. If you can prove that the z-score that corresponds with it is less than -2, then we definitely know that we're looking at it being a unusual value, aka significant value. Over 2 greater than +2 or equal to +2, then we definitely see it as a significant value, or see we have. And same thing happens. If it's in between -2 and +2, somewhere in between, but not controlled, then we know that it's going to be usual, aka not significant. We're seeing the same thing happen. The whole group is standard deviations. So we're going to go ahead and hit this prompt here real quick. And first, we're going to be pretty much introducing the empirical rule. I do hit the fact that in the bottom is going to have the bright light that's right here. But what I'm going to do is, I guess I'm going to go ahead and split the values here on top, okay, just for the heck of it. And because we have plenty of spaces, I'm going to use it for other things, but I do have the side work with that. We'll go with that. And so we're saying here, okay, the weighted candy canes are ball-shaped or pocket ball-shaped with a mean of 32 grams and a standard deviation of 6 grams. 4 of the candy canes have a weight or have the weights of 21 grams, 13 grams, 42 grams, and 52 grams. State which weights are significant or non-significant values. So are they significantly high, significantly low, which one, if they are significant? Or not state that they're not significant. Or go to the usual, unusual. So first and first, we're going to go ahead and build the curve room. One thing you should do by z-scores or using this idea. But what we're going to keep in mind here, we have to keep the key information like always. What we're seeing here, key information, our mean is going to be 30 grams, and my standard deviation is going to be 6 grams. So that's what we're going to keep in mind and use to our advantage. So over here, if we want to, we have our mean, which is going to be, in this case, 32 grams. And we have a standard deviation, which we know is supposed to be 6. So typically, what we're doing, if you're doing by hand, we're just typically adding to the 6 this way to get to the next one over, which is pretty much going to become 38. Then we're going to do the same thing, add another 6, which should become 44. And we're going to add another 6, which should become, in this case, and on. So this is getting to the standard deviation. So over here we have our 1 standard deviation away, our 2 standard deviation away, our 3 standard deviation away. That's what we're seeing there. We're looking at the z-scores. And over here, 0 standard deviations is right in the middle. And something to the left, we'll do the same thing, so minus the 6, which will pretty much give us, in this case, 26, minus another 6, which should be giving us 20, minus another 6, which is going to give us 14. And we can still go on. to get to the fourth one. What we're deficient here is here's a -1 standard deviation, -2 standard deviation, and -3 standard deviations away from the mean. So that's what we do by hand. What you guys do, you can take the calculator and with that there of noting that these guys are here are z's, while these guys are here were x's that we found by doing the standard distance standard plus. So how do we get we should recall once again the z. If you want to find z using x's, what we know is supposed to be x minus x bar over standard deviation for sample, or it would have been x minus mu over the sigma or population. Here's this we already know, or we should. But I'm not trying to get z from x values, I'm trying to get x values from z's. So what I'm looking for here is actually knowing my x's and obtaining from the z's, which is supposed to be the mean plus the z times the standard deviation for a sample, or if we're doing a population, we're looking at it being pretty much mu plus the z times the standard deviation. And we're seeing that here. So all we're doing here is we're getting the z-score and telling you about the standard deviation. If they connect, they're running the same. So I can do a calculator, and what I'm going to do here is under this one, I'm just going to put those corresponding z-scores. So I'm going to start at -3, even though we should be going to -4, but we start there because that's where my 68, 90, 95%, and the 99.7% are within those two standard deviations. So then -3, -2, -1, 0, 1, 2, and 3. And over here in list 2, we can get, remember these are the z-scores that we're seeing, and these are supposed to be corresponding x-scores at list 2. So what we're saying to do here is, well, I use this expression. And what I'm saying here is my list 2 is going to equal pretty much my x bar, my mean, plus my z's, which are on list 1. So I'll put over here list 1. And we're going to times it by the standard deviation. That's all we're going to do. And we put that to our formula, and we're going to get what should go here for the x's. And we'll see that on the calculator. So, first thing here, looking at the TI-4s, we go to stat, like we usually do, edit, and this one, I want to put my z-scores. So here we go, -3, -2, -1, 0, 1, 2, 3. So I got those guys in it. So I got those guys in there. Now I'm going to go for my z-scores, or for my, of course, my x's, which here I'm going to highlight the list 2 like always, do the list operation, and I'm going to just put it here, my mean was supposed to be 32, plus my list 1, that's where my z-scores are at, and I'm going to times it by my standard deviation, which is 6. So notice how I get the exact same results. I mean the exact same results as we did during the standard way. So 14, 20, 26, 32, 38, 44, and 50. Or the theory saying here, when z is 0, we still have a mean. Okay? That's what we're seeing there. So how we do for the calculators, or similar for the calculators. So I'm going to go ahead and pick out the Inspire real quick. Okay. Inspire purpose is the same thing. Just turn it on. Make sure you have a new document open. So pretty much, mine already opened it once, so I'm going to go to current, and already had these open up for us. So what I'm going to do here is pretty much under this region, I'm first label my list. So this one will be the first one. Enter, and this will be the second one for now. So once again, we have to label your list for the Inspire. So now I come over here into this region, and I do the same thing, -3, oops, let's take a 6. -3, -2, -1, 0, 1, 2, and 3. So I'm good. I got all those guys in there. So I'm going to now here, I'm going to highlight this equal part. That's where my expression is for my list 2. And I'm going to press enter. So I say, okay, list 2 should equal what? Well, list 2 should equal, once again, we're looking at the mean was 32 plus the parentheses of list 1. And also the parentheses, we're going to multiply it times 6. And we say, what do I want to do? Make sure you're doing variable. Don't do cell, because cell is only one thing. I'm looking at all of them. So I want the whole variable to be affected. And same thing over here for, so that was for list 2, we want to affect everything? Yes. Now for list 1, do I want to use everything? Yes. I want to use everything for list 1. So that's selected. Now come over here and enter. And there it is. Same thing. But one more thing over here for you guys, make sure when you're done, print it out. Because you can't make any adjustments. Oops. So that happened. That's because I say, okay, and enter it. Okay, the second quit. So 14. Okay, we'll cancel. So I'm going to come up here, and I'm going to clear it from here. So second clear, it's gone. So now when I come in here, everything will get affected, just a few things will get affected. So don't watch out for the Inspire. When you don't get expressions, delete it. Unless you're doing it from the calculate, it'll just store it automatically. But anyways, that's that. Now let's get the seals. Where's those guys got the seals? Something's happening. For concealers, make sure you're in the stat view. So make sure you menu and then you have you're selecting statistics. Something's happening. I got this guy. Take a quick. Come over here. I'm gonna do the same thing. So -3, -2, -1, 0, 1, 2, 3. All my z-scores. And I'm gonna do the same thing. Oh, and I did this too, huh? How smart. Don't worry, I can do this real quick. Now I'm gonna put here this one. Sure, this is good. I'll clear that guy. -3, -2, -1, 0, 1, 2, 3. And I'll clear these guys off. There we go. So in list 2, make sure this guy's highlighted, and I can start doing my expression. So 32 plus the parentheses of this 1. So shift 1 to get this in there. And my calculator is very sensitive for my touch, so make sure you just put this 1 with the parentheses, times it by over here, or times by 6. Okay, same thing. We're just doing the same thing over and over again. Just for different calculators. So I got the same result each one. So from the z-scores, I got the corresponding x scores that corresponds to the empirical rule. So with those that are done, we can actually do some answering here. So now it's actually the question. It says, okay, fine. Okay. Which of these guys are in the significant range or in the non-significant range? So let's look over here. So well, 21. Well, 21, if I'm looking over here, I notice that it is a little bit, it's between 20 and 26. It's in this range right here, 21. And we clearly see that, hey, it is definitely in the border. Okay. We know everything out here is significant, everything out here is significant. So it's not in the significant realm. So we're definitely seeing here that, well, it's pretty clear that 21 is less than, it's actually, we're wrong. It's greater than the 20, but less than the 44. Okay. So we're definitely seeing that over here it is definitely not significant. Let's look at the next one. The next one we're seeing here is 13. Oh, that's weird. We're seeing, 13 now, if you look at it, look where 13 is located. 13 is definitely out here in its range. Okay? So I'm clearly seeing that 13 is definitely less than or equal to the 20, which is the 2 centimeters away from the mean. So we definitely see this guy as being significantly low. So there we are, significantly low. Let's go to the next one. The next one we're seeing here is 42. Let's look over here, and we're seeing, 42 is definitely between 38 and 40. So 42 is in this region. Okay. So it's clearly not in the significant range. So we're starting to see that it's within the 2 standard deviations. So 42 is in here. And we know that that is not significant. It's not significant value. And lastly, we're looking at 52. And we can clearly see over here, 52 is beyond here. So it's definitely in the realm of that is considered exceedingly high. So we'd like to see here that 52 is greater than 44. And we're seeing it as being, exceedingly high. There we are. And that's where we're using the Perker rule. So once we have both the parameters for the Perker rule, where we have definitely the mean and the 1, 2, 3 centimeters out, both directions, that holds the 68%, the 95%, and the 99.7%. Or we figure out what's happening over here. So let's just say, okay, fine. What if they were asking to do the Perker rule, aka the range rule of thumb, and I was supposed to use the z-scores instead? How would this change? Well, how would we be adjusting? Well, instead of going from z-score to measures and comparing the measures, what we're doing here is we're looking at the measures that we know, and we're going to be comparing to the z-scores. So what we're doing here is we're going to find the z-scores using the measures. That's what we're going to do. And we're going to see that right now. And the coolest thing is, you can still do this operation with these guys if you don't notice. But I'm going to show you the formula. I'm going to erase this guy right here, show some formulas, and we're going to see, if we get the same thing, if we do this operation, we have more than one, within the same standard deviation and mean formula, we're comparing them on the same list, in the same group. When you have different groups, you have to do them separately. But anyways, come over here. I'm going to erase this stuff, but we don't need this stuff no more. We're focusing on these guys right here. And I will change the slide right now. So here we go. Center values. So now, notice we're doing the same information. The only difference instead of using the Perker rule, I'm going to use the standardized values. That's one difference that I'm doing here. So these guys will have different results and different claims, but I'm just going to go ahead and note that for the first one, what we had was the 21, okay, which was the x value. And we're going to be getting corresponding z. The second one was supposed to have been the 13, x equals 13. And we're going to get the corresponding z. Then it was the 42, x equals 42. And we're going to get the corresponding z. And over here was 52, x equals 52. And we're going to get the corresponding z score. When I say z, I mean z scores. But anyways, here we go. So for the 42 one, we definitely see that we see that we came from a sample. So our z is going to equal, well, over here we know that we're looking at x is equal to 42. So our z is going to equal pretty much 42 minus the mean, which is 32, all over standard deviation, which is 6. And pretty much we just do the work, simplify, and get to a conclusion. Or we're pretty sure we're going to 10 over 6. We're going to figure out what that is. And we're always going to approximate to 2 decimal places. So I want to have 2 decimal places when I'm done. When we approximate, so I'll put an approximation right here. Wrong. We always want to round to 2 decimal places. Are we going to see the same time for the other ones? Going so over here we're trying to compare the x equals the 13, 1. We're seeing the same thing happen, where you have our z, make sure you color, our z is going to equal the 13 minus 32 now, all over the 6. And we'll see what happens there. And then the next one, I should have named the colors, but I didn't. For the x equals supposed to be 42. Well, I like. The first one was 21. I did the wrong one. 21. I get z is going to equal the same thing. 21 minus 32 all over 6. I'm going to find its approximation. And then lastly, was x is going to equal to 50. And it was 52. Okay, so since I'm using the same, I'm in the same group, it comes to the same formula, the same expression. That's what we're showing. So I'm just going to quickly do this operation for this. Sure. These are all the same. So I'm going to just do pretty quick. You have to do one individual one. Just like you quit. There we go. So on this 3, I'm going to just put those x values, those x scores. So I'm looking at pretty much, if we're going to order it's supposed to be, I'm supposed to put 21 first. Then it's supposed to be 13, followed by 42, followed by 50. Okay. That was the order. Okay. So I'm saying that, okay, this right here should be my list, this is my list 3 right here. That's all I made, list 3. Okay. And now I'm going to find my corresponding z's, okay, using list 4. Okay, so question, how I'm going to find this? Well, I'm going to use this formula. I'm going to put this formula into the expression. So I'm going to do. So what I'm looking at here is I'm going to say, well, I'm going to get parentheses, and I'm going to get my my x values, which is my list 3. All my x values. I'm going to subtract the mean from it, okay, which is going to be 32, and I'm going to divide it by the standard ratio 6. That's what I'm going to do. And my list operation. So that's what I'm over here for list 4. And you can do the same thing for all the calculators. I'm going to do this one because I will show you how to do this for all of them. So therefore, this follows the same process on your calculator with the list operation. So here I go. So I'm going to do, first I'm going to do list 4. On this one, I'm going to start writing it. So it's going to become pretty much in parentheses, 2 parentheses. I'm going to do the one in parentheses. So I'm going to do list 3. Close the parentheses. I'm going to subtract the mean from it, which is 32. I'm going to divide by the 6. Okay? So I'm getting that in an expression because for this calculator, you can't do fractions in it. You have to do the expression, so know how to do group of symbols when it comes down to it. So now when I enter it, I get these z-scores. And my job is to run off to the nearest 1, or the nearest 2 digits. So when I look at the 21, which is right here, I'm seeing that my z should be negative 1.8. Get the right one? Yeah. Yeah, negative 1.83. For the 13, which is right here, I'm ending up with negative 3.17. Coming here for the 42, I'm ending up with 1.67. And then for the 52, I'm ending up with 3.33. So clearly we're seeing something important here. If we look at the z's, which is very important. We're clearly seeing over here, well, this guy here is not more than 2 centimeters within the mean. So therefore, we could live right here less than, well, what we don't here is pretty much the z we found is less than positive 2, that's what we're seeing. Okay, but also greater than negative 2. So it's in the in-between round. Over here, we're definitely seeing that the z that we found is less than negative 2 away. It is negative 3. Maybe I should put in the numbers in there. 1.67. Over here was negative 3.17. Over here, we're looking at this guy is definitely in between the two standard deviations. So we know it's in between 2, negative 2, and positive 2. And we clearly see this one's greater than 2, so we're definitely seeing it being 3.33, that's greater than 2. So the code is in, we're ending with the same result as before, as we're seeing that. And let's talk over here. Well, we cleared, I wrote on that side, smart for me, but I had it next to that guy. So we're definitely seeing the same thing over here, and we're coming to the conclusion that we get the same result for the 21, which is supposed to be the negative 2 less than negative 1.83 less than 2. It's in a non-significant region. So I'm just going to write the same thing over here so I don't have to do too much writing. So we're clearly seeing that this one here was not significant. We're clearly seeing that this one here is significant because it's definitely beyond 2 standard deviations away from the mean. So this one here is significant. Below, over here, not significant because it's in between. We're going to see this one as being significantly high. So we're ending with the same thing. So for those guys who want to see how the list operations work for the other one, because remember, the reason I did this operation is because we were dealing with the same meanings, we were dealing with the same group, the same meanings, the same standard deviation, so I thought the same. But usually they're different, mean standard deviations, unless you ask for multiple things. Then you could do it all at the same time. Okay? But anyways, I guess I'll quickly show it for all the calculators, how I get the same result on the other calculators. So I'm going to just put this one off to the side, and I'm going to bring up my TI-84 for right now. And we're just doing the same thing. We're just going to repeat the same process, okay, but on your calculator. So over here in list 3, like I had before, the one we were supposed to have first was 21, followed by 13, followed by 42, followed by 52. And I'm going to do the same thing. I'm going to go highlight this, and over here, you guys are supposed to press enter, and then now you write the expression, parentheses, and we're looking at pretty much list 2. Sorry, list 3 for this one. Close parentheses, minus the standard deviation, 32, close parentheses, that's on the fraction, and divide that by the standard deviation, which is supposed to be 6. And notice how I get the same results, the exact same results. They're kind of small, I do apologize. This screen is, this black line is not really that great into showing it in a better manner. But anyways, there we go, we have the same results that we got over here. So now we got the inspire, and we're going the same way. So those you guys have inspire. Let's turn back on. Bring this guy down. So first, I'm making another list. So this way here, I'm going to firstly label. So list 3. Enter. And then over here, list 4. Enter. So now I got my list. So now I'm going to start building them. I'll build the same way. Over here, it's going to be the same thing, 21. Enter, 13, enter, 42, enter, 52, enter. So I got all of them in there. So now, since we're all doing the same information, same separation, I can do them all at the same time. So when here in equals, I'm going to do the same thing. I'm going to press enter to get it to start equaling, and I'll start to build the expression. So we're looking at parentheses, another parentheses with the list 3 in there. So outside the first parentheses, subtract it. So we'll subtract the mean from it, which is supposed to be 32. And outside that, we divide by 6. Okay. And enter. And once again, it always has to be cell. So I want to open up our cell variable. Make sure always choosing variable for each one of them. Okay. And there it is. We have the exact same results for each one. Oh, notice over here is fractions, but that's okay. That's because when I didn't do the approximate. So come over here, just do your control equals, and it should be approximating. Okay, it didn't approximate. Okay. This is what I do. Come over here, I'm just going to clear that. So it's second clear. It's a good thing I showed you that system. So over here, we don't want the fractions, we want the decimal. So over here, I'm just going to do control approximate, and it should be able to do it. Control approximate. It's not doing anything. Okay, fine. So that's not a good thing. But let me try something real quick. I forgot that it does fractions automatically over here. So come over here on the calculate. What I'm going to do is I'm going to call upon the list 3. So we're going to list 3 on list 4. So I'm going to do list 4, call upon it. And what I'm going to do from here, I'm going to do control, enter. Now I got it approximated. So now notice how this 4 is doing approximation. Let's hope and see it's doing it over there in the other side. Okay, if not, I'm going to do this. I'll start to do this. Let's see. Didn't do it. So what I'm going to do is I'm going to come over here, go back to my calculator, and I'm going to store it. So I'm going to do your store function, which is right here. So control store, and I'm going to store it to list 5. Sometimes you have to do your operations on the calculator side. Okay? So it's been stored. And now what I'm going to do is I'm going to go over here. And right here, I'm just typing this 5, and it should be in decimals. It should be. Enter. There you are. Decimals. So it turns out, I do apologize for those who have inspired. I totally forgot that when you put operations in this and do it with division, it's going to automate the fraction. So for you guys, what you really have to do, you have to go into calculate and do your storing when you're doing the division ones, because it's going to be the case all the time, and you can't convert. At least I don't know at this time how to convert within here. I thought when you do the equals, you can convert them, but you're not converting either way. So this. Go ahead and keep it like that. Do it on the calculator, store it to the list, and just call it on the list, and it will come up in decimal form. Okay. So pretty much that is everything for this session for unusual values. So we learned how to do it using the Perker rule, so using the actual X measures and the Perker status, how we use these scores to get the measures right away without having to do the subtraction individually. But again, either methods can be possible for you. And then how to find using the Z-scores. Because remember, you have to know how to do either one, both of them. So make sure that you know how to do both of them, depending on how your teacher wants to teach it to you. Okay? But anyways, stick to the next one, and we're going to be doing more of the Z-scores comparisons of performance individuals, and also going into the whole standard deviations and comparing spreads.